Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And today it's going to be a really quick video on how the SNS SQS Fanout pattern works. Now, I have seen that most developers and architects understand how the simple notification service or SNS works and how the simple queuing service or SQS work. They understand the true power of SNS, which is sending the real-time notifications to the subscribers, and they also understand the true power of SQS, which is building the resiliency in the event-driven applications. Now, I'm going to combine the true power of both SNS and SQS in what is known as the SNS SQS fanout pattern. So let's get started. In today's video, we will delve into the fascinating world of the SNS SQS fanout pattern. We are going to explore how to effortlessly send the messages to multiple subscribers to create a loosely coupled system and ensure the reliability of your applications. It is all possible with the SNS SQS fanout pattern. So, if you are a developer, architect, or are just curious about how modern cloud-based systems handle the event communications, you are in the right place. We will break down the core concepts, delve into the real-world use cases, and provide practical insights into how this pattern can simplify your life as a cloud engineer. So without further ado, let's dive right into it. Before we truly understand how the SNS SQS works, let's take a quick look at how SNS works. In this diagram, you can see that SNS uses the publisher subscriber approach. Publisher is nothing but a service that is ready to send messages. And it could be an ECS Fargate container, an EKS pod container, a Lambda function, or any other web API. Whenever they are ready to publish the message, they use the SNS, which is the simple notification service, to send that message. There are subscribers that subscribe to that topic. So subscribers could be Kinesis, Data Firehose, an SQS, step functions, Lambdas, emails, SMS, HTTPS subscriber. It could be any kind of subscriber. And if they have subscribed to a topic of a particular type, they will receive that message. Let's also take a quick look at how SQS works. I know I have covered the SQS in detail in one of my previous videos, where I covered the SQS, the dead letter queue, the visibility timeouts, and the delay timeouts. So if you're interested in finding out more, you can watch one of those videos. But essentially, SQS works very similar to SNS, where the difference is that the consumers are polling the SQS to get the messages. So imagine a scenario where multiple publishers are sending messages rapidly to the SQS. Those messages don't get delivered in real time. Essentially what happens is they get put at the back of the queue. So whenever the consumer is ready to poll, they'll poll and they'll pick the messages that are at the front of the queue. So essentially, imagine a scenario when multiple publishers are sending messages rapidly and you have a large number of messages in the queue. So the consumers won't really consume the messages in real time, but at least there is a guarantee that the messages are going to be received. SNS is slightly different because SNS sends a message and guarantees delivery at least once. But imagine if the consumer, in case of SNS, is busy or is not able to process the message is gone. So SNS does not offer as much reliability as SQS offers. So that's why we use the SNS SQS pattern, so that you can take advantage of real-time notifications, but at the same time take the advantage of the reliability of the SQS queues. Now that you understand how the SNS and SQS work individually, let's take a look at the SNS SQS fanout pattern. You see on this diagram, you have a publisher, which could be a service, which is ready to publish the message. It publishes the messages on SNS, and you can have multiple SQS queues that are subscribed to that particular topic. And that's where the term fanout comes, which means the mechanism which simplifies the process of sending notifications to multiple destinations without needing to manage the individual connections or endpoints for each subscriber. It basically decouples the publisher of the message from the subscribers, enabling the scalable and flexible event-driven architecture. So essentially, in this scenario, you had a publisher that just publishes the message and doesn't care what is on the right side. It doesn't care how many consumers want to receive that message. Based on the subscribers subscribe to a particular topic, they are the ones who are responsible for taking the message further. So that's the whole principle of SNS SQS Fanout pattern. Now, you might be wondering, why do I need the fan out pattern instead of directly publishing to the SNS subscriber? And I will cover some reasons briefly on why you need that. First is the decoupling and resilience. By using the SQS queues as intermediaries between the SNS and the Lambda function, you decouple the producer, which is the SNS, from the consumers, which is the Lambda functions. This decoupling provides resilience and fault tolerance. If you know that the SNS just guarantee one-time delivery and it's essentially throwing over the wall, but using the SQS in between, you can configure the retries, you can prevent the message loss. Second reason is the scaling and parallel processing. SQS can handle a large number of messages and allows you to scale the number of consumer Lambda functions easily, which is not possible with the SNS. You can have multiple Lambda functions polling from the same SQS queues, enabling the parallel processing of messages, which can lead to faster message consumption during the high loads. Third reason is the batch processing. SQS supports batch operations, allowing Lambda functions to process multiple messages in a single invocation. You can play around with that setting in the AWS console where you can set the batch size. I think by default it is 10, but you can play around with it. This reduces the operational overhead and cost associated with invoking the Lambda functions for each message, which would be in the case of SNS. The next reason is the rate limiting and throttling. You can control the rate at which messages are consumed from the SQS by adjusting the concurrency settings of your Lambda functions. This helps in preventing sudden spikes in message processing, which could overwhelm the Lambda functions. We've talked about the dead letter queue, so I won't go in much details, but with SQS, you can also have the concept of dead letter queues. So for some reason, if the consumer, which could be the Lambda function, is not working or throwing some exceptions, SQS handles sending those messages to the dead letter queue, and from there they can be retried after a certain duration. So this prevents the messages from getting lost. Next reason is the asynchronous processing. The SNS to SQS Lambda pattern enables the asynchronous processing, which can improve the overall system responsiveness and scalability. It also allows the Lambda functions to process messages when they have available resources rather than being invoked synchronously in the case of SNS notifications. The logging and monitoring, I will not cover that in much detail because I've already covered that in previous videos, but it allows you to track the message delivery, queue status, and potential issues, which if you're just using the SNS, you will be scratching your head. I've had multiple sessions where I've used SNS for direct communication, and once the message is lost, if the Lambda function was busy, you are stuck in a debugging hell. Cost optimization. SQS is also very cost effective for storing the messages, while the Lambda functions are built based on invocations and execution time. So it's also very cheap. By using the SQS as an intermediary, you can control the rate at which Lambda functions are invoked, potentially optimizing costs. So, in summary, the SNS to SQS Lambda fan-out mechanism offers improved decoupling, scalability, resilience, fault tolerance for event-driven architectures, and also is very cheap. While it introduces an additional service, which is the SQS, into the flow, it often results in a more robust and manageable system, especially when dealing with high volumes of asynchronous events. So, if you found the value in this content useful, please hit the subscribe or the like button, and also let me know in the comment section what other videos you would like to see next. Thank you for now.